really, really fancy. It's not. Then we're going to talk about what? There's a formula? Yes, there is. Permutation formula. Then we're going to do some questions, and then you got time to work. So welcome to the exclamation point. You may have seen it in the math world. You may have seen it on your calculator. Probably didn't have a clue what it was. Now you get to know. First off, this doesn't mean N, like we're really excited. That's not what the exclamation point means in math. We don't even call it an exclamation point. We call this N factorial. And I did win the ultimate Trivial Pursuit game on this question. It was, what is the exclamation point in math? Yes! Which, by the way, I had to delete Trivia Crack. Can't do it, can't do it. Wasn't getting any work done. Couldn't do it anymore. Addictive. So again, this is an excitement, although this is really exciting. It's not called an exclamation point, it's called N factorial. What does it mean? Well, let's start with 5 factorial. What it means is 5 times 4 times 3 times 2 times 1. And how many times already in this course have we written 5 times 4 times 3 times 2 times 1? All it is a short version. Instead of having to write all that out, 5 factorial means the exact same thing. What do you think 8 factorial means?
Always write all of that. 8 times 7 times 6 times 5 4 times 2 times 2 times 4.
Whew, that was a lot to write out. Well, nobody writes that out. We write 8 factorial. What does N factorial mean? N times, well, how did we go from 5 to 4, from 8 to 7? Minus 1, so N minus 1 times N minus 2 times N minus 3, and we keep doing this all the way till we get down to 1. That's all it means, is take the number and keep subtracting 1 until you get down to 1, then multiply it all. It's just a fast way to write all those numbers multiplied out because mathematicians are lazy people. Here's the ones you need to know. 2, 3, 4, 5, and 0. Anything larger than that, you'd be able to use your calculator. So 2 factorial. Tell me first, what does it mean? 2 times 1. What's 2 times 1? 2. 3 factorial, what does it mean? 3 times 2 times 1, so 3 times 2 times 1. Yeah, because mathematically it's still there. 4 factorial is 4 times 3 times 2 times 1, so 4 times 3 times 2 times 1, 24. 5 times 4 times 3 times 2 times 1, we already wrote that above. 5 times 2, or 5 times 4, 20 times 3, 60 times 2, 120. 0 factorial. Yeah, you'd think, but no, it's 1. And I'll tell you why when we get down to the examples. Remind me, because I forgot with the other group. Remind me to come back to 0 factorial. Well, what if it's something huge like 8 factorial? Well, this is all built into your calculator. Let's do it on the calc first, then we'll write how to do it. So just put your pens down for now, relax. It's not called an exclamation point. What's it called? Factorial. Which the rumor is, and we have no idea if it's true, but apparently when they were picking a symbol, they looked at the keyboard and said, what's not already assigned? And the first thing they saw was the exclamation point. I know, it's pretty lame. So if you're doing a large factorial, first thing you want to do is put the number. We're going to calculate 8 factorial. Now I'm going to go into the math menu. So I hit my math button. You have 2 choices now. You can tab 3 to the right, or you can do 1 to the left. I do 1 to the left because I'm lazy. And what you should be on is what's called PRB, which stands for probability, because this actually has a whole bunch of stuff to do with probability. And what do you see in the list? 4. Number 4. And then hit enter, bam, calculator does it for you. Let's just test 0 factorial and show that it's 1. So 0 first. Then, not second function, just math. PRB, number 4, enter. Write down whatever steps you need in the box to remember that. So we're going to do some questions on simplifying factorials because we'll need to use that later on. And these show up on the non-calculator section of the exam. And so when you first look at this, you're like, WTH, Ms. Thompson, you said we didn't need to know anything bigger than 5. I know, because there's a little trick to simplifying these. No, that's way too easy. Okay, so what I'm going to do is take 10 factorial, and I'm going to start to write it out in its long form. So 10 factorial we know is 10 times 9 times. Now, I don't want to write out 8, 7, 6, 5, 4, 3, 2, 1 because I'm lazy. I'm just going to write that as 8 factorial. So do we agree that 8 factorial is 8 times 7 times 6 times 4 times 3 times 2 times 1? Well, why did I choose to stop at the 8? Oh, look at this. What's going to happen? So 10 factorial divided by 8 factorial equals. There's a way they can sneak this onto the non-calculator section. This is called simplifying factorials. If you're a wordy person, break down the larger number. Break down the larger number. Break down the larger number until you can cancel with the smaller number. Break down the larger number until you can cancel with the smaller number. Okay, part B, 12 factorial over 10 factorial. Which one is larger? 12 factorial, so we're going to start breaking it down. It has to be 12 times, 11 times. And why do I want to stop right there? Because we can cancel with the smaller one. 12 times 11. This would be a 1-mark question, maybe a multiple choice question. Oh, but then they'll try to trick you and throw these n's in here. If you're not sure which is the bigger, just pick a number for n and substitute it. Let's pick 9. So the top would be 9 factorial. The bottom would be 7 factorial. Which one's going to be larger? The top. So we're going to start by breaking it down. N factorial is n times n minus 1 times n minus 2. Stop. Why do we want to stop there? And then we're going to multiply just like we would with any kind of question with n in it. So n times n. N times minus 1. D, n factorial over n plus 1 factorial. Which one's bigger? The bottom. How do we know the bottom is bigger? Because it's plus 1. Again, if you're not sure, just pick a number. 12. So the top will be 12. The bottom will be 13. Okay, so we're going to leave the n factorial this time. This time we're going to break down the bottom. What does n plus 1 factorial start with? N plus 1. How do we get the next number? Minus 1. So n plus 1 minus 1. Stop. Why do I want to stop there? Because it matches the top. I'm going to show you a really, really, really common mistake that we see all the time on the exam.
1 over.
Yeah, people think when you cancel, the bottom can just magically float to the top. What's left on the top when you cancel? 1. Questions so far? Okay, so that was simplifying. Let's go back to our permutation type questions. First one's just a straight up, no restriction, nothing fancy going on. Read to read. Take a breath at the end. Slow your blood pressure. Most important stuff. Does it matter they're different? So yes and no, I heard.
Yes, yes.
And tomorrow we're going to talk about what's called permutations with repetition, so when things aren't different. In the second sentence,
Different toilet. How many?
how many blanks? How many choices of song do we have for the first song in this playlist? How many do we have for the next one? 4, and then? Ugh, and mathematicians are like, no, I'm not writing that out. Bam, 5 factorial. It was so hard on Monday not to talk about 5 factorial. 5 factorial you have memorized, or you're going to memorize. It's one of the ones we need to know. 5 factorial is, there you go. If you prefer to write it all out and have a number in each space, great, go for it. If you're lazy and just want to write the 5 factorial, that's great too. That is the, do you have to show the blanks? No, not even in this one. Okay, let's do some restrictions. You're telling me what to highlight.
4 digits. How many? Repetition is not allowed.
What are the restrictions in this question? Not repetition. Only those numbers. Only 4 digits. So 3 different restrictions we have going on here. How many blanks? How many choices for the first digit? Okay, can't repeat, so how many choices for the next number? And then, you've memorized, or you're going to memorize 4 factorial is? Bam. Factorials make our life easier if you're lazy. How are we feeling on factorials? Yep, I'm getting them, kind of getting them, not really, Good. Okay, let's talk about the formula. What? There's a formula and you didn't tell us? So we call this the permutation formula. We read it as NPR. N and R are always subscript, so they're smaller and lower. N represents the number of objects. That's not hashtag of objects, that's number of objects, okay, just so we're clear on that. R is the number of choices. So N is how many things do we have, R is how many do we need to pick. You'll often hear people call this N pick R, just because we're picking things. Formula is equal to N factorial over N minus R factorial. That's why I couldn't tell you on Monday, because you didn't know what a factorial was. N minus R factorial. Go on, go ahead. Someone asked the question that somebody asks every single time I give you a formula and we put it in a box. Is this on the formula sheet? Well, how could you find that out? So look at that. Slip can't be buried because it's longer than everything else. Is it on there? Where is it? On the right side at the, on the bottom. If you've noticed, the formulas have pretty much been in order to what we've done so far. Okay, so yes, it's on there. Just a note off to the side. There's an old notation for NPR that we don't use, but textbooks will use it. Your professors in university might use it. Ooh, notation. So NPR you'll often see written as NR in brackets stacked on top of each other. This used to be great. It was lovely. We used it for years and years and hundreds of years. And then physics people were like, wait a second, that's a vector, which if you haven't done physics, don't worry about what a vector is. But if you've done physics, you'll know that word. That's a vector. Yes, it is. And so then we were like, ooh, vector, permutation. So the math people were like, okay, physics people, we'll come up with a new notation. That's what we chose, NPR, because it can't be confused with anything else. That has to be a permutation. That would take me about 3 years to explain in physics. Okay, so how do we use this formula? What's its purpose? We're going to do the exact same example we did on Monday. We're just going to do it both ways. So I'm going to show you first with the FCP, which stands for Fundamental Counting Principle, and then I'm going to show you with the formula. FCP is the blanks. So this question is 3 people, 5 desks. How many blanks? 3 or 5. How do we know what number of blanks? You go with the smaller number. Why? Yes. Yes, why? Because if you go with the larger number, what are you going to end with? You're going to have zeros, right? We know we can't multiply by 0, so we know it has to be 3 blanks. Person number 1 walks in. How many desks do they have to choose from?
5.
They sit down. Person number 2 walks in.
4.
Person number 3 walks in. And what do we do with these 3 numbers?
Multiply.
Why?
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 Because.
Okay, because you told us, because that's the way it is, because math is magical are not good answers. Why?
That's how many options there are.
Yes, and there's a little keyword in the notes we talked about on Monday. And we need the first person to sit, and the second person, and the third. And always means multiplication. 5 times 4
20.
times 3.
6.
Okay, so that's the way we did it Monday. Nothing has changed. Still a great method. I'm just going to show you how to do the exact same question with the formula, and you can pick whichever way you like. Formula says we have 5 objects, and we need to pick 3 of them. So we read that as 5 pick 3. Formula says that it's n factorial over n minus r factorial. N in this case is 5. And on the bottom, we're going to have 5 minus 3 factorial. Bed mass. Factorials is just multiplication, so we have to do the brackets before we can do the multiplication. So on the bottom, 5 minus 3, 2 factorial. Now we just practiced simplifying factorials. So take the larger number, break it down, which is larger, 5 or 2.
5.
Okay, so let's start breaking it up. 5 times, 4 times, times. Why do I want to stop there? And I'm just going to pause for a moment, take a look at what we had on the left, take a look at what we have with the right.
Is the smaller number always going to be the one after me?
Yes,
Yes.
yes.
Okay.
Okay. The other way we could have done this instead of simplifying is we could have said that we know this is 120 and we know this is 2 and 120 divided by 2 is, okay, so that's the other way to use the formula if you know the factorials. It's completely up to you. I'm a blank person because I see it better when there's restrictions, especially when you have the people who have to be together and don't want to be together, and these numbers have to and greater than and less than. Formula I'll use if it's a straight up, just no restriction, but it's completely up to you which way. You need to know the formula because sometimes the exam question will just say simplify, and they'll just give you 5p3 or 8p6 or 9p2, and you still have to be able to simplify it even if you don't use it to do normal kinds of questions. Well, what if it's really, really big and we don't want to simplify it? Let's do 5p3 on the calculator.
5.
The 5 goes first, so the n has to be typed in first. Then I'm going to go back into the math menu. You either tab 3 to the right or 1 to the left, end up on PRB. And what do you see in there? Number 2.
Oh,
And then
3.
we put in our R value. Bam. Write down whatever you need in the box to remember that. I just want to go back to the formula for this a second. There's actually 3 restrictions on this formula that I want to talk about. I'm going to write them down. Restrictions we've done before, but restriction on a formula just means conditions on the variable. So there's certain numbers that n has to be and can't be, and there's certain numbers that r can't be. So don't lose track of what these definitions are. N is the number of objects. Can you have a negative number of objects?
No.
Could I seat people in -2 desks?
No.
Could I have a decimal amount of desks? Could I have 7.2 desks? Could I seat 4.3 people?
Average.
If we're talking averages, but we're not. We're not talking extra limbs or Siamese twins, right? Normal, everyday people. So what kind of numbers does n have to be?
Positive.
So it has to be positive, and it has to be whole numbers. So how do we word that? Well, we're going to say n has to be greater than or equal to 0, comma. N is an element of
Reveal. Oh, whole numbers. Integers.
integers. Why integers if we can't have negatives? Because we've already defined it here that it's positive. What about R? R is a number of choices. Can I choose -3 people?
No.
Can I choose -2.7 people? So what do we know about R?
R cannot be named.
R has to have the same restriction, has to be bigger than 0. R is an element of the integers. What about the relationship between n and R? So how are they related to each other? And Noah actually said this about 3 minutes ago. Why does n have to be greater than R? Right, so can you choose more objects than you have? No. So the third condition is n has to be greater than or equal to R. There's the 3 conditions on the formula. Okay, if you're a wordy person, it means n has to be positive and a whole number, R has to be positive and a whole number, n has to be at least R or bigger. Okay, we're going to take a brief interruption before we go on to the examples, and I'm going to blow your little math minds. This we've been waiting to tell you since grade 10. So excited. Remember him? Yeah. So what the heck does he have to do with permutations? Well, here's the actual formula for sine. Yes, it's O over H, but that's not what your calculator does when you're calculating it. The formula for sine is x minus x cubed divided by 3 factorial plus x to the 5 divided by 5 factorial minus,
2.
follow the pattern, x to the 7 over 7 factorial plus
X to the 9 over 9 factorial minus x to the 11 over 11 to the factorial.
forever. What the heck is that? Look at that. Who figures this stuff out? So look at that sign we started with on the very second day of the semester, and we're coming right back to him in the very last unit. What about cos?
Oh, it's going to be even.
Cos is 0 factorial minus x squared over 2 factorial plus,
X to 4 over 4 factorial infinity.
let's do a few more just because this is totally fun. Forever. What do we call numbers that go on forever?
Infinity. Infinite.
I'm like cringing there. What do we call numbers that go on forever?
Rational.
Kind of. Irrational. So this has to do with irrational numbers. It has to do with sequences and series, which you did in grade 11. It has to do with factorials, which is in permutation, and all trig. Does that not freak you out just a little bit? Someone in the other class said, so like math is all connected? Yes. Remember E? What's E approximately equal to?
2.788.
And that comes from, it's actually 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial dot, dot, dot.
But isn't 1 over 0 factorial just 1?
Yes. And isn't 1 over 1 factorial just 1? Yes. Oh my God. Who figures that out? Who knows that? Well, let's just try that in a calculator and see what's going to happen. So let's do 1 over 0 factorial. How do I get 0 factorial?
Math.
0,
Math.
math,
Left.
left, 4. Okay, and then I want to add
1.
1 divided by,
Oh, you need brackets.
no, because there's no other term, so
1 factorial. So 1 math. Left. 4.
ooh, I didn't mean to add yet. Ooh, I didn't mean to enter yet. Plus
1 over 2 math. Left. 4.
plus
1 3 math. Left. 4.
plus
1 4 math. Left. 4.
plus.
Oh, 1. Right.
Look, and we've only gone up to 5, and look how close we are to E. Okay, so eventually we're going to keep adding, adding, adding. It's going to get super close to 2.781, or 2.718. Thank you, Euler. How did you figure that out? I have no idea. Look at that. Seriously. Math is like a mystery. I don't think he was guessing and checking. I think he probably knew some stuff. 5, 6, 7 are unique kinds of questions. We're going to solve what we call permutation equations. What does it mean to solve?
Find missing variable is.
Ooh, I like that. Find what the missing variable is. Now, we could guess and check. We could start throwing numbers in and using our calculator and figure out how we're going to get 30, but that's never going to get you the full marks in an equation. What this means when it says solve, it means algebraically. So if you just guess and check and you happen to come upon the answer, you'll only ever get 1 mark out of whatever it's worth. So what we're going to do is step number 1 is we're going to use the formula. So I'm going to take out NP2 and I'm going to put in the other side of the formula. NP2 has to equal n factorial over n minus 2 factorial. So that's just right from the perm equation. So if you're a wordy person, step number 1 is use the formula. Now, we already practiced this kind of stuff on the left-hand side. What are we going to do with it? We're going to simplify. So step number 2 is simplify the factorials. Which one do we want to break down, n or n minus 2? N. So we're going to start by breaking it down into n times n minus 1 times n minus 2 factorial. Why am I stopping there? Why don't I keep going? Multiply through what's left, so n times n. I already heard someone say n squared minus n. What kind of equation? How many ways are there to solve a quadratic? And they are.
Graphing. Quadratic formula. Difference of squares. Completing a square. Wait, what did Derek say?
Factoring.
Oh, square root.
Square root. High five. Pick a method and solve it.
It's factor.
Oh, now you all love factoring. You hated it in grade 10. Hated it. Now you're all over the factoring. Except for the Brazilians.
Better than the quadratic.
It is a way of life in Brazil. It only takes long because we haven't practiced it a bazillion times.
I guess you could say they practice it from Brazilian.
Ah, that was good. That was good. That was quick. That was good. A Brazilian times. I like that.
I'm so disappointed in myself.
You had to. You had to jump on that. Offer of minus 6 plus 5. Split and solve.
6 and minus 5.
Are they both valid answers? No. Why not?
You can't have negative n.
Can't have negative n. What do we call that when there's an answer that we cross? Extraneous root. What's the answer? 6. Again, we could have guessed and checked. We could have done 6p2 and figured out it's 30. That would have got you 1 out of 3 marks for this. Number 6. Ooh, we missed step 3. For the people writing it down, step 1, formula. Step 2, simplify. Step 3, solve.
Convert to the formula.
Use the formula. Okay, so NP3 equals
N. Factorial. Or n minus factorial.
there's the offer. Okay. Step 2. Why did I go all the way to n minus 3 when in the last example we stopped after n minus 2? Because we have n minus 3 factorial on the bottom. Oh my goodness, how am I going to multiply this out? How am I going to multiply that out?
N squared minus n.
So you can multiply them in any order. I tend to do the binomials first, but it's completely up to you. I like to FOIL, so I like to do that first. N times n.
N squared.
The outside, n times negative 2. The inside, negative 1 times n. And the last, negative 1 times negative 2. Let's just simplify the middle terms right now. So agree the two binomials, n squared minus 3n plus 2. Okay, then what do we do with this n out front? Multiply them through. And let's bring the 60 over. What kind of equation? Cubic. We spent 3 classes on how to solve cubics.
Longer. Synthetic division.
Something with synthetic, but that's not the first step.
Guess and check.
Guess and check, and you're looking for something that when you plug it in gives you 0, and then once you find one that gives you 0, then synthetic, and then you take the answer from synthetic and
Guess and check. Or factor.
factor, and then
You got
do it again. Go to. Yeah, you have an exam. Oh, by the way, in 10 classes, 10, we're on to hands now, 10 classes. Does anybody have the quadratic you get from the synthetic? N squared plus. Okay. Confirm that's what you get after the synthetic? Okay. And you probably went to factor this, and what happens? You can't factor. There's nothing you can multiply to get 12 but add or subtract to give you 2. So what does that tell you about this second piece? No, you can solve it because there's 4 other methods. What does it tell you if you can't factor? The numbers aren't going to be whole numbers, right? If you're going to use quadratic formula, you're probably going to get a negative or some decimals in there. What do you know about negatives and decimals in terms of n in the NPR formula? So if you can't factor, you don't even need to bother solving it. It's done. Okay, so you might want to make a note. If you can't factor, the answers are not whole numbers. If you can't factor, the answers are not whole numbers. So if this was just a normal solving a cubic from Unit 5, you would go forward and solve it with quadratic. Because we're doing permutations and we know n has to be a whole number, we're done. What does n have to be? 5. That wasn't so bad. Number 7. Oh, look at this bad boy. Okay, step 1. Okay, what do I do with this 2n? Yeah, just leave it. NP2 equals? So step 1 is formula. What is step 2? Simplify. And we've done n over n minus 2 twice now. Which one are we going to break down? And it's going to be n times n minus 1 times n minus 2 factorial. So what's going to happen with that? Okay, so if you want to jump that step, that's fine. If you want to put it in there and show it, that's fine too. Okay, now what? Okay, so get rid of the brackets. Okay. What kind of equation? Quadratic. I too am like, whew, it's not cubic, I'm not going to lie. Cubics are a lot of work. What do you say? Complete the square? Square, oh, you want to factor? Mm-hmm, hated it before. Offer of plus 8 minus 7. Split and solve. Are they both valid? That was an exam question 3 years ago, maybe 3.5. That was a 3-mark exam question. Mm-hmm. Last one for today. turn and talk. So don't write anything yet. Just talk to your neighbor about this question.
We got it.
It's right, so it's wrong. Never say that. What he said is right.
So don't forget your exam has normal, straight up calculate questions like the last one, but they also like to throw in these explain why questions to see if you really understand or you're just repeating what I've told you. This is a 2-mark exam question, so you have 2 points in your answer. So you're always should be checking the points, making sure you have enough. Why?
Because the one on the left has to be bigger than the one on the right.
How would we say that mathematically?
R has to be, yes, R has to be smaller.
And
O
has
has
to
to
be
be greater.
greater than or equal to R.
That will get you 1 mark. But that's not enough, because that you could have just regurgitated from what I told you. You need a because. So what does that mean in terms of this situation? So why?
Because it's not allowed.
Yeah, so because Ms. Thompson told us, because math is magic, because the math gods say so, none of those are going to get you the extra mark. Okay, you need to show me you understand what this means. Because math is awesome, yes, not going to get you the mark. Why? So we still need more.
You can have more
And so,
objects.
okay, so I'm like where Noah's going here, because
You can have more choices and objects.
you cannot choose more objects than you have. Another way to do it would be to show the formula. So if you have NPR, and in this case is 3P8, that's going to equal
Uh, 8.
the top is the N, 3 factorial,
3 minus 8.
and 3 minus 8 would be negative 5 factorial. But again, why?
You can have a negative.
Because N,
Cannot be negative.
and mathematically, how do we say that?
N has to be greater than or equal to 0.
There you go. That would be your 2 marks, or this would be your 2 marks, either way. Okay, so when you do the explain questions, you want to have some kind of math rule, and you want to have some kind of explanation for it. This is your math rule, this is your explanation, math rule, explanation. Again, it can't be because it's that way, because somebody said so. Just because, not going to get you the 2nd mark. How are we feeling on permutations in general? I like them, I kind of like them, I'm not.